All right, so let's try to finish up that lesson that we started yesterday. We got just a little bit further with you guys yesterday than the other class, not too much. Okay. All right, so let's make sure this is working. Yep, it's working. All right, let's just start off where we started, or where we ended off yesterday, but we'll go right back to the beginning of it. So let's draw a line segment, and we'll call this A, call this part right here B, and we'll call this one way down here at the end C. And do you remember what they did? They made that length 6x minus 1. This is probably already in your notes if you took notes yesterday. If not, if you didn't take notes, now's your chance to do it. All right. And they told you this. Here's what they asked you to do. This is example 2 in the book. And they said to find, let's try to make that look a little nicer. Okay. Find AB and BC. And then they said if AC is equal to 75. Okay? What do they mean, find AB? What are they talking about? When you see AB with no line over top of it, what does that mean? Come on. It's the length of, right. It's the length of AB. All right? We're trying to find how long AB is, that line segment. And we're also trying to find what else? How long BC is. Exactly right. Now, right now, we can't tell because I don't know what. What don't I know? I don't know X. That's right. I got to find X. Okay, that's what I have to find. If I know what X is, then what can I do? Plug it in, right, for the X and then figure out what it is. I don't know. I'm just going to make a number up. Okay, what if X was 2? What would AB be equal to? No, not 12x minus 1. If I said X was equal to 2, it's 6 times what? 2, which is 12, and then 12 minus 1 is 11. It's not 11x, it's just what? 11. Okay, you with me on that? What would this be if X was 2? Now it's not, I'm just saying if it was. I just picked a super easy number. So yeah, 5 times 2 is 10, plus that 10 is 20. Everybody got it? Okay. But we don't know what X is, do we? I just made that up. It is 6, but how do we get to that? Glad you asked. Now look at this part right here. AC is 75. Sometimes I like to do this. I like this little thingy right there. I remember when I was a kid taking math classes and we started doing these braces thing. I was such a nerd, but I would sit there and practice how to do them because I couldn't do them very well. So I would take my time. Sometimes I do them better. That one looks better than that one. But I would take my time to do that. But anyway, now I can do it fairly well. All right. So why did I do that brace right there? Because I'm trying to find that whole distance from A to C. Well, they tell me the whole distance from A to C. How much is it? They tell it to me. It's 75. That's right. They say if AC is 75. So they're telling you that the length of AC from here to here is what? 75. I like to put that on my picture. It helps me visualize it a little bit better. And I don't know, just a little nicer to do it that way. So what is AB and BC doing to make 75? This little bit right here and this little bit, well, the bigger bit right here, BC, what are those two doing to each other in order to get to be 75? They add up together. That's exactly right. Okay, they add. You see that? Remember what we did yesterday? I forget what numbers we used in my other class. I think I used 3 and 5. Let's just go back in time a little bit. Forget all these. What if AB was 3? And what if AC was, I don't know, let's make it 10. What if? Okay, it's not, but what if? So what if this little bit right here was 3 and the whole thing was 10? How would I find BC? I would subtract, okay? What if I just knew this? What if I knew that this was 7? All right, So if this little bit was 3, this little bit right here is 7, how would I find the whole thing? I just add them up. 3 plus 7 is what? 10. You with me on that? Okay. So hopefully that gets your mind thinking about what you do to those line segments, right? Segment here, segment here. What do I do to those two right there to make the whole thing? I add them up. Got it? So what am I going to do now? What is line segment AB? I kind of know it. I don't know it exactly, but I kind of know it. What would I call it? How long is AB? It's right there. It's right on top of it. It's 6x minus 1. That's exactly right. Okay, that's how long AB is. Everybody got it? The only problem is, what's the problem? I don't know what x is, do I? Okay, but that's what we're going to find. All right? But I do know that the length of AB is what? 6x minus 1. And what am I going to do to the length of BC? What am I going to do with AB and BC? We've said it several times. I'm just going to get you to repeat it. You add them together. That's right. Okay? I'm just trying to get you to keep thinking about the adding. All right? So I take AB and I add it to BC. Well, what is BC? What's the length of BC? It's 5x plus 10. That's right. So what am I going to do? I'm going to add, you see it? Well, we'll do that in a second. I'm going to add 5x plus 10. So here's AB, here's BC. I'm going to add them up, but they tell me what they add up to be. What do they add up to be? 75, exactly right. They add up to be 75. This is where we ended yesterday, okay? And I told you, apparently you don't remember that, but I told you to work on this on your own last night and come up with an answer. And it doesn't seem like anybody did, because when I asked, nobody said a word. Well, anyway, let's do it together. Let's add some like terms, like you said earlier. All right, this is where all that that algebra review stuff that we did earlier, right, in the year, comes into play here. This is where it's happening, right here. We did, what, almost 3 weeks of review from algebra just so we could do this problem right here, all right? Not just, because we're going to do a lot of this kind of stuff. The rest of geometry class, all right, we're going to do this. So let's add some like terms. I got 6x plus 5x. What's that? 11x, all right? I like to mark them off so I know I'm done with it. What other like terms do I have? Well, this is a what? It's not a 1, but it's a negative 1 plus 10. What's negative 1 plus 10? It's plus 9. Positive 9, so we put a plus there. And that equals what? 75. Now we go through and we solve for x. All right, we've done that before. We've had quizzes on it and everything else. So minus 9 from both sides. That cancels. Bring down the 11x. 75 minus 9, 66. I'll give that to you. Okay, Josiah, you writing this down? Come on. Right? There's no reason not to be writing this. Then what do we do? Divided by 11. Cancels. X is. Is that my answer? Do I circle it? Do I go to the next problem? Nope. Why? What are they asking for? AB and BC. Okay, AB is not 6, BC is not 6, but X is 6, correct? Remember what we said before? What if X was 2? We plugged it in. Well, I said before, X is not going to equal 2. What does X equal? Equals 6. So what are we going to do to find AB? So let's do this. So AB equals what? 6 times, I'll just write it out. 6x minus 1, okay? So let's plug it in. Let's take that 6 and plug it in for x. So what is it? 6 times 6, then minus 1. 6 times 6 is 36 minus 1 is 35. So AB, the length of AB is equal to what? 35. So this length right here, okay, is equal to 35. I'll put it right there. So how do we find BC? Same thing, but we're going to plug it in for what? 5x plus 10. Right, BC. Good. So let's do that. So BC is 5x plus 10, correct? We're still going to put the same x in for it, okay? X is still 6 right there. So I'm going to put a 6 in for the x. So it's 5 times 6 plus 10. Should be able to do this now, right? What's BC now? 5 times 6 is 30 plus 10 is 40. That equals is in a weird spot, isn't it? Let's put it right there. And BC is 40. And there you go. You're done. That's what they asked for, isn't it? They asked you to find AB, and they asked you to find BC, and we found them both. Now watch this. I want to show you a little easier way. Did anybody see this? There's a little bit of an easier way to find BC instead of plugging it into 5x plus 10. Look at it. Look at what I got right here. The whole thing is 75, right? And we found this little bit right here is 35. What's an easy way to figure out BC without plugging a 6 into 5x plus 10? Subtract, say it.
Subtract 35.
You got it, okay? So go 75 minus 35, right? Because the whole thing is 75. We found this, so I can just go 75 minus 35, and what is that? That's 40, isn't it? So it works both ways, doesn't it? And it should, all right? Make sure that it does, all right? And you don't have to do it both ways. You can do it this way if you wanted. It's perfectly fine. But once you find one, you can just find the other one just by subtracting, okay? So what do you think? That's your very first geometry problem where you used algebra. It's the very first one that we've done. But it's not going to be the last, all right? We're going to be doing this a lot. We're going to be doing this with other things, other shapes, okay, and figures in geometry. We're going to be doing it with all kinds of things, especially with angles, and that's what we're going to get to, well, in a second. We've got one more thing to do with a line segment, but we will get to angles here in just a couple minutes. If you didn't understand this, go back and watch the YouTube video, all right? That's why I record them. That's why I put them up there. Okay, if you didn't understand some of the steps, go through it, write it down yourself. If you weren't paying attention in here, it's a perfect opportunity to go home and do it. Now, I would rather you pay attention in here the first time and write it all down. But if you don't, then you can always go to the YouTube. All right, let's do another one. So we're going to learn another word here. So there's a line segment. Okay, we'll call this line segment XY. And then what I'm going to do, see on this computer program, I don't know if you can see it, but there's like a little blue dot right there. Where do you think that dot's located? Right in the middle, right? So I'm going to put a dot where that blue dot was. Okay, a point. Put a point there. So it's right in the middle. So I'm going to call it M. All right, makes sense, doesn't it? Now, right now, as you're looking at this, do you know for 100%, pretend you didn't see me put the dot on that blue dot, okay? But can you tell me 100% that that point M right there is dead in the middle? Like if I just put it on a piece of paper, if you just walked in, could you say that that absolutely 100% is dead in the middle? It looks like it, right? Would you agree? I think everybody agrees it kind of looks like it. Does that mean it's exactly in the middle? No, I could be off just the smallest little bit. You'd never be able to tell just by looking at it, okay? I could be off by 0.00001 millimeters, okay? Which is very, very small, right? But it's not in the middle then, would it? All right, so I can't just say it's in the middle right now. But there are a couple ways that you could tell if it's in the middle. One is that they put some tick marks on here. Remember the tick marks from yesterday? So if I put a little tick mark here and a little tick mark there, what does that mean? Now when you walk in the door and you see this line segment, now you can say that XM is equal to what? YM or MY. Yeah, either way you want to say it. All right, you see that? Those tick marks mean that this line segment, XM, is equal to this line segment, MY. So if those two line segments were exactly the same, here, I think I got a couple pens that are, I think these are exactly the same, okay? So watch. One line segment is here, the other line segment is here, okay? And they meet and they're exactly the same length. What must be true about that point where they meet right there? It's in the middle. Okay, you follow me? If this was equal to this. What if this was a little shorter? I'll take the cap off, okay? So now, it's just a little bit shorter, isn't it? Not much, but it's a little bit shorter. So if I put them like this, is that point where they meet in the middle now? No, because this is not the same length as this. You got it? But if they're the same lengths, then where is point M? In the middle, okay? But we're going to use a different word than in the middle, okay? This point that's in the middle, okay, I'm leading you up to something. This point that's in the middle is called, it's got a special name, and it's called the mid, what do you think? Point. All right? So that point that's in the middle is called the midpoint. So if this is in the middle, it's called the midpoint, which means that line segment, the length of line segment XM is equal to the length of line segment MY. All right? If those are equal, then M is in the middle. Again, we rarely say in the middle when we talk about geometry. We usually say that point is the what? The midpoint. Okay? Everybody with me? All right. That's all for midpoint. Let's do this. I did this in the other class. Let's do it now. I think it's good. What if I put like a 3 right there? And I asked you to find MY and XY. What does that mean? Find MY. Find the what of MY? The length of, okay, or the measure of MY. So you should just be able to look at it right now and tell me without doing any math what MY is equal to. It's 3. MY, not XY. Talking about MY for right now, okay? MY is exactly the same as XM because of the tick marks. Got it? So that's 3. What's XY equal to then? It's 6 because XY is from here all the way to here. I add up the 3's and I get 6. All right, so that's 6 and that's 3. That's the kind of stuff that they could ask you about midpoint. But guess what? They're not just always going to put numbers here. What do you think they're going to do? They're going to put some variables in here like this, okay? I can't think of one off the top of my head that works out really nice, but I'm just going to make something up, okay? So what if I said that this is 2x plus 3, and this is, 3x minus 1? I really doubt that this will come out nice, but at least we're going to set it up. So what if I told you that xm was 2x plus 3, and I told you that 3x and that my was 3x minus 1? What could we do to set up a little algebra equation like we did on the last problem? Do I add them up? Do I go 2x plus 3 plus 3x minus 1 equals something? Why would I not do that? Because I don't know the what? I don't know the total length. That's right. I'm not told the total length. I don't know what it is. But I do know what about this and this? That they are what to each other? They're equal to each other. So guess what I'm going to write down? I'm going to write 2x plus 3, what? Equals what? 3x minus 1. I think this actually does come out kind of nice. So let's do it. All right? Let's get x on the same side. So I'm going to subtract a 2x just to keep that positive. And then what are you going to do? Add a 1, right? So what do you get? 3 plus 1 is 4. What's 3x minus 2x? 3 minus 2. Come on. 1x, right? Okay, and that cancels. So what's x equal to? It's x is equal to 4. Is that what I asked for, though? Well, I didn't ask for anything. Let's do this. Let's find xm, and let's find my, and then let's find xy. Let's find all 3 of them. So how would I find xm? What's xm equal to? 2x plus 3. What did I just find? I just found x, which is 4. That's right. So let's put it in here. 2 times what? 4 plus 3. 2 times 4 is? 8 plus 3 is? 11. So what's xm? It's 11. Do I even have to put that into this? Do I even have to do any math? Why not? Because if this is 11, talk to me, the other one's got to be 11 because they're what to each other? They're equal to each other, right? So this should be 11 as well. Just for the fun of it, let's plug it in and make sure it is. All right? Let's just do it in our head. X is 4, right? So 3 times what? 4 is 12. 12 minus 1 is 11. It does work, doesn't it? What if I ask for xy? What is xy equal to? 22. That's right, because we add them up. xy is that whole thing, right? So from here to here is 11, here to here is 11. The whole thing is 22. So technically the work is 11 plus 11, which you can do in your head, equals 22. We good? That's the kind of stuff that you're going to see the rest of the year. I hope you get it now, because it's really going to help you out the rest of the year, because you're going to see that a lot. Wow, you're going to see it so much. I can't express to you how much you're going to see that kind of stuff. In every single chapter, we're going to do that kind of thing. All right, enough of that. Let's go to angles, all right? We know what an angle is, but what we're going to talk about today are a few special angles, 4 of them in particular. There's a lot of special type of angles, but these are the 4 that we're going to talk about. You know what an angle is, right? It goes like this, and and it goes like that. Let's just briefly talk about angles again. An angle is made up of 2 what? 2 rays. Very good. 2 rays, okay? And the rays of the angle are called the sides of the angle. So that's a side of the angle, and that's a side of the angle, right? They meet at a common point. We give that a name. That has its own special name. What do we call that special point where they meet? It's not a midpoint. Well, it's the end point of both rays, but there's something special about the angle, okay? There's a word that we use for that point on the whole angle. It's the vertex. Very good. That's the vertex. Okay? Everybody with me? All right. Yeah, good enough. All right, so those are angles. It's not a special angle. It's just a basic old angle. What we're going to do, we're going to do some special angles right now. So, you ready? I'm going to go like this, and I'm going to go like this. My guess is, you've probably seen this at some other point in your math career. First of all, is it an angle? Sure it is, because you got 2 rays with a common vertex right there. Okay? Here's something, again, you've probably seen. This is probably not the first time you've ever seen this. So I'm going to put a little box right there. You ever seen that? Yeah, you've seen that before. What does that mean? It's 90 degrees. That's how we measure angles. We measure angles with degrees, not in centimeters or inches or anything like that. Okay, we measure it in degrees. So if we put a little box right there, that indicates that this angle is 90 degrees, right? Everybody with me? So like going straight across here would be 0, and if I come up to here where it goes straight up and down, that's at 90 degrees. So this is a 90 degree angle, but we have a special name for it. Anybody remember what that is? It's a right angle. Okay, it's a right angle. Again, this is something you probably were taught, I don't know when. It's been a long time since I've been in elementary or middle school, and I really haven't taught elementary at all. I've taught just a tiny little bit of middle school. Anyway, now you know it. That's 90 degrees. What if I draw another one? I'm going to draw another angle, and we're going to draw it like this. Now, tell me something about the degrees of this angle compared to the degrees of this angle. It's less than 90 degrees. Good. I'm going to write that in there. So it's less than 90 degrees. And we have a special name for an angle that's less than 90 degrees. Acute, right? And again, this is something that I'm pretty sure I'll put acute angle. That's the symbol for angle. Remember that? Right? So that's an acute angle. An acute angle is less than 90 degrees. Simple. These are words we need to know because they're going to talk about acute angles, right angles, and all these other things, okay? So you got to know what they're talking about. That's why we got to hit this stuff. Let's do another one. And I bet you could guess what this next angle is going to be called. Very good. See, I was right. And again, this is good. I'm glad you're saying these words because now I know your math teachers back in the day were doing their job. All right, so this angle right here, look, it goes beyond 90, right? 90 would be there, but it keeps on going. So it's more than 90 degrees. Or we say in math, don't usually say more than, we say greater than. Owen? Give me a pass. All right, this is greater than 90 degrees, and we have a name for it. What is the name? We already said it, but say it again. It's obtuse, right? Obtuse can also mean other things. Like if you told somebody that they are obtuse, it basically means they just don't know what they're talking about, okay? That they're not that bright, maybe. You can look it up. I'm not sure the exact definition, but when people say, you are so obtuse, that's not a compliment, all right? It means you don't know what you're talking about, basically. But not in geometry. Geometry just means it's bigger than 90 degrees, okay? It's an obtuse angle, all right? It's greater than 90 degrees. We got one more. Everybody writing this down? If you're not writing it down, that makes it easy to fall asleep, and I can see some of you guys nodding off already. It's because you're not writing stuff down. So write stuff down. So here's a ray. Now watch this. There's the endpoint right there. Now look at this angle. This angle, I'm not going to go like this. I'm not going to go straight up and down 90. I'm not going to go like this. That's another type of angle we could talk about. We're not going to talk about it right now. But what if I did this? It went completely opposite. We talked about this yesterday. They're called opposite rays, but it forms an angle. Isn't this an angle? A lot of people look at it and say, that's not an angle, Mr. Hamrick. It's just a straight line. But it's two rays with a common vertex, isn't it? And so two rays with a common vertex is an angle. So yeah, this is an angle. Josh, you said it. What is it? It's 180. So if I went from there to there, that is equal to, I'll put equals, 180 degrees. And what does it make? It makes a what? Makes a line. And a line is straight, isn't it? Makes a straight line. So what kind of angle do you think we're going to call this? A straight angle. Okay? So we don't call it a straight line. We call it a straight what? Angle. So what's a straight angle equal to? 180 degrees. All right? Again, this is stuff you're going to see, right? It's going to pop up on the homeworks and all that kind of stuff. You need to know what these words mean. Let's do one more. This one has a little bit to do with the right angle. All right? This time I'm going to have two lines that intersect each other. All right? Let's say they intersect like this. Doesn't matter where they intersect each other, but they do intersect each other. But look at the angle that they make with each other. What does it look like that angle is right there? It looks like a right angle. Do I know 100% right now just that that's a right angle? I don't. It could be like 89.99999 degrees. Is that 90? Nope. It's close, but it's not. Okay. It could be 90.00001 degrees. Is that 90? No. But if I put a little box there, what does that tell me? Now it tells me it's 90 degrees. So I know I have a right angle. But what I want to do is I want to talk about the lines themselves. So I'll call this one AB, and I'll call this one CD. All right, so we got those two lines. I bet you this is another word that you've probably heard before. If I have two lines that hit each other at a 90-degree angle, we say those lines are what to each other? Starts with a P. It's not parallel. We talked about parallel, didn't we? No, maybe that was my other class. Parallel means they never touch. Well, these touch. These intersect. So they're not parallel. They're what? Perpendicular. Very good. Have you heard that word before? Perpendicular? Yeah, I'm sure you have. All right. So it's perp. N-D-I-C-U-L-E-R. Perpendicular. Okay. So these two lines, they're lines that are perpendicular. The angles aren't perpendicular. What are perpendicular? The lines are perpendicular. Okay. I have a symbol. right? We got symbols for all kinds of stuff. Got symbol for line segment, for ray, for angle, for all this kind of stuff. Well, for congruent, right? We did that yesterday, right? Had a sign for congruent. Got a sign for less than, greater than, all kinds of symbols. Well, we got a symbol for perpendicular, and here it is. It's just a straight up and down line and one that goes across. Somebody in the last class says it looks like an upside down T. Sure, you can think of it that way as well. All right, it's an upside down T. That's the symbol for what? For perpendicular, okay? So if I wanted to say that these are perpendicular, let's say this. Let's say we didn't have the box. Could I say right now, looking at this, the way it's written, without the box, could I say that they're perpendicular? No, I don't know. I mean, it looks like they are. It's pretty close, right? I don't know 100% that they're perpendicular, but they could do this. In the instructions, they could tell you, and again, a lot of times they use this word given, and they could say that line AB, so I got to put the line symbol over top of it, so line AB is perpendicular, right? There's the symbol. Let's make it look a little bit better than that. It's a little better. All right, so AB is perpendicular to what? What's the other line? CD. I mean, I could make this BA or make it DC. That doesn't make any difference. But this right here tells me that this is perpendicular. Those two lines are perpendicular. So now, knowing, the book told me that they're perpendicular, so I have to believe them, all right? So what could I say about that angle right there? It's a 90-degree angle. It's a right angle, okay? Everybody with me? What about this angle right here? It's also a right angle, isn't it? Why? Because you got a straight line. How many degrees is a straight angle? A straight angle, 180, okay? And if this is 90, how do I find out this one? 180 what? Minus 90, which is what? 90, okay? What's this one? That's 90. What's this one? That's 90, okay? We don't have to put all three of them there. It's just understood. If you have two lines that are perpendicular, all four of these angles are going to be 90 degrees. We good? Yeah. All right, we're getting there. We're getting there. All this is crazy important, okay? I'm just telling you. I'm just thinking ahead, and you're not because you haven't seen the course before. You have no idea, right? I'm just trying to tell you what's ahead of you. And this kind of stuff is ahead of you, all right? So make sure that you know what perpendicular lines and all that kind of stuff means, because you're going to hear it, you're going to see it, we're going to deal with it all the time. Yep. All right, let's do another one. One of the last things we talked about yesterday were congruent segments. Do you remember that? Do you remember the symbol for congruent? We did it yesterday. What was the symbol for congruent? Congruent kind of means equals, but it's not exactly. Yeah, with a little, what kind of line? Little squiggly line. Let's make that a little more squiggly. There we go. All right, so that right there is the symbol for congruent. All right, what does that mean to be congruent? Well, it means if you took one, you took the other, and you put them right on top of each other, they would be exactly the same size. Okay, so we talked about congruent segments yesterday. Today, we're going to talk about congruent angles. And basically, it means kind of the same thing as congruent segments, except they're not segments, they're angles. So if you took one angle and picked it up, put it on top of the other one, matched it up, it would match up perfectly. All right, that means they would be congruent. So let me put a couple angles here. All right, we'll just make it like that. What kind of angle is this? Acute, very good. All right, and I'm gonna group this so I can copy it. Group it, and then copy it, then paste it. There we go. All right. Now, what did I just do? I copied and pasted, right? So this angle, if I picked it up, if I can pick it up. Oh, come on. Come on. Why can't I grab it? There we go. All right. If I picked it up and I put it right on top of this, it would be exactly the same. Do you see it? All right? It's exactly the same if I lined it up correctly. All right? Let's put it there. So what must be true about those two angles then? They must be what kind of angles? Congruent angles. All right. Even if I change the direction like that, are they still congruent angles? Absolutely. Okay, because they have the same measure, the same angle measure. So let's do that in a different color. So let's just say that that was 30 degrees. That's less than 90, right? It's an acute angle. Let's say it's 30 degrees. Then if they were congruent to each other, then this would be 30 degrees. Makes sense, right? All right. If this was 30.01 degrees, would they be congruent? No. All right. They'd be close, but not close is not enough. Here's one way that you could say, I'll call this angle A, and I'll call this angle B. I don't need 3 points because there's only one angle coming out of here. All right, so I could just call it by its vertex. Here's a way that you can show, like on a piece of paper, like right now, again, like I said earlier, you walk in the door, you sit down, and you look at those two angles. Could you say that they are congruent to each other the way they're looking right now? No. All right, I mean, they look like they are. They look like they're the same angle, don't they? But you can't say 100% that they are. All right, but here's what will tell you that they're congruent. If I put a little arc, not a tick mark. Remember the little tick marks on the segments where you just put a straight little line? This is an arc. This is curved. All right? That doesn't look very curved, but that one looks a little better. If this has one arc and this has one arc, then what can you now say about these two angles? They're congruent to each other. Very good. All right? So they are congruent angles if you know that. Here's another thing. What if they didn't give you the tick marks? Okay. Now, remember we put the 30 in there before? If you put both of them are 30, yes, you could say they're congruent because they're the same degree. What if they told you this? What if it was given? They don't always say given, but what if it was given that angle A, well, yeah, well, this is silly. But anyway, here's another way to say they're congruent. They could tell you that angle A is congruent to what? Angle B. So that's another way that you know that they're congruent. If they flat out tell you that those two are congruent, then you know they're congruent. All right, pretty self-explanatory. Everybody go to that? All right. You know what I'm going to do? I'm just going to quit there. That's where we ended with my other class. We still have a few minutes left in here, but you guys have been pretty good. A few of you are nodding off, so I might as well stop here. And plus, I'll be at the same exact spot I will be with the other class. So that's where we're going to end up. You guys take notes on this. Just remind me tomorrow where I ended up. All right, and then we can continue. So we'll finish it up. I'm not going to give you any homework tonight. I think I split that up into two, didn't I? Yeah, I gave you 1 to 14 yesterday. But again, a lot of you still can't get in your lockers, but we'll figure it out. Okay, so we're going to be off just a little bit from the lesson plans, but we're just behind maybe half a day. All right. I'm not going to collect those just yet. Okay, so I'll collect them. I think they said today they're going to do the judging of the hallways, and so we'll be able to get to your lockers after the judging, and then you'll be able to get your book and all that. So you should be able to have your book by the end of today. All right, so make sure you take it home. Do that 1 to 14. All right, make sure that 1 to 14. I will collect that tomorrow. Everybody got it? Some of you guys are already finished it. Most of you probably already finished the 1 to 14. So get that finished. I'll collect it tomorrow, and then I'll assign part B tomorrow. Everybody got it? Again, so we're like a day behind. That's okay. We can deal with it.